Assalamualaikum students, how are you all? Hope so you are all good. Okay, let's start our today lecture beta. In today lecture we are going to explore chapter 2, that is our database environment. Here are the table of content of chapter 2 2.1, that is a 3-level architecture. Chapter 2 section 2.1 is 3-level architecture, and next we have 2.2, that is mapping, data independence, data models. And in this lecture we have to deal with these. Next we have type of data model. This is also related to the section 2.4 data models. So we shall cover this week these 5 topics. First one, what is the 3-level architecture? Next we have data mapping. Next we have data independence and data models and types of data models. Basically emergence or related to the section 2.4, means 4 topics we have: architecture, mapping, independence and models. Okay, let's start our today lecture. First one, what is a 3-level architecture? Now, first of all, we will study that the 3-level architecture, also called ANSI SPARC architecture. What stands for ANSI? ANSI means American National Standard Institute, and SPARC means Standards Planning Requirements Committee of ANSI. Okay. So this model is represented by this committee, and this is initially invented, described, published by this committee in 1971. What about this model? Means we have to come to the 3-layer architecture definition. That means the 3-level architecture, also known as ANSI SPR architecture, is a framework that separates the user's view of data from the way the data is physically stored. A framework that separates the user's view of data from way the data is physically stored. Means, what does it mean? If you are seeing that picture, first of all, we have top level is external level, or you can also call it user level. User level of data is abstract, away from the physically data, where the data is stored in the database, and where our database is located or positioned is hiding, perform abstraction from the user. This is called a 3-level architecture. What is the purpose of this architecture? Is that the purpose of this architecture is to provide the data abstraction from user to required physical data, meaning the user do not need to know the complexity of the data is stored or managed. User doesn't need to know about the where data is coming and how data is arrived to their destination. They just want data. How it comes to them, they didn't need about that. Okay, they just interact with the part of database that is relevant to them. Okay, that's why it separates what the user sees and what the database design creates and how the data is actually stored in the computer. This 3-level architecture mainly important just because of these 3 terms. First one, it separates what the user see and what database designer creates and how the data is actually stored in the computer. And now we have come to this figure. In this figure you can clearly see we have 4 different layers. First one, external, that is also called the user view or external level. Second, conceptual level, and third one is the internal level, and fourth one is the physical data organization, where the data is actually stored. It's called a physical data organization. Okay, now come to the above 3 levels. This is also known as a 3-level architecture. First one is the user. So users, on this level we have separates the users from below 2 level. how data will created by the designer. This is done by the conceptual level, and internal level, this is also known as physical level, how data is actually stored in the system, कि किस तरह से आपका डेटा स्टोर्ड हो रहा है इन द सिस्टम, इज कॉल्ड अ इंटरनल लेवल और फिजिकल लेवल स्कीमा. ठीक है. And on the conceptual level you have database designer, system designer. ठीक है. और आपके पास सिस्टम डिज़ाइनर जो इनपुट दे रहा है, दैट इज एंटर्ड इनटू द कॉन्सेप्चुअल स्कीमा. बट आपका कॉन्सेप्चुअल लेवल जो है वो किस तरह से मेंटेन हो रहा होगा और वो कौन कर रहा होगा, वो इंटरनल स्कीमा कर रहा होगा, और इट इज़ डन बाय द database administrator. Means simple words, you can see that you can say that at internal level all functionalities are performed by the DBA, and at conceptual level all functionalities are performed by the database designer. Next we have further elaboration of these three levels. First one, external level, or we can also call a view. We already discussed in the class what is the view. View is basically a schema or structure. Schema means structure. Structures mean we have a form of representation of the data. This is also known as a table or relation. Now come to the these three levels one by one, step by step. And first one we have that the external level, also called a view level. At this level, what the end users see, this is called the external level. Okay. The user does not need to know about the full database, only their own view. They are interested in only their own required view or data. This is basically closest to the user, and it defines how the individual users view the data. We must say we have multiple users. Okay. For example, if view 1 is about the student, and view 2 about the faculty, and view 3 about the dean, so doesn't mean they have all same data. They just external level tackled how the individual users view their data according to their respective needs. Every user may have different view depending on their needs. This is the concept of external level. For example, if we are take an example, imagine you are a bank customer. You can log in and check into your account and balance, but you cannot see the other customer's balance. Okay. So this is basically the relevant example of external view. Okay. You can also see some example over here in the book also. For example, if first view, the name is Ali Raza, and second view Raza Ali, and so on. Third view, okay, this is the basically one person view, but they need some different information. In first one they need date of birth, next state, department, yes, state it requires, and next one we have some combination of these, yeah, age and so on. So number of attributes are different in these views. Okay. Entity is the same. Key point of external level view is that to hide the complexities and provide the customized view. This is the main theme or concept of the external view. What the external view, yeah, external level done. External level hides the complexity and provides the customized view. Next, forward to the logical or conceptual level or view. Okay. In this module level, complete the logical structure of entire database. Okay, we already discussed in the class that means we have a, if we want to go for the architecture and it gives us some blueprint for our gray structure or some house designing a structure, so this blue structure is known as logical or conceptual view. Okay. In similarly terms in database, when we have blueprint of database, yeah, schema, yeah, design, yeah, ER diagram is known as a conceptual, yeah, logical view. It includes all entities, relationships, and their constants and their associations. Okay. Next we have, it represent the entire logical structure of data. Okay. And if we are going for some example over here, if we have in bank, we take the bank example, there are tables of customers, accounts and transactions, different tables, and what are their attributes of that tables and what are relationships between these tables, whole hierarchy or conceptual schema about that organization is known as logical या conceptual level. ठीक है. Next we have key point, that is the conceptual level is complete design of database that shows how everything fits logically together, means a complete blueprint how actually exist in the database. Next we have internal and physical level. This is our last 3 level architecture. In the internal or physical level, this shows how the data is stored physically on the computer, basically where the data is stored. Okay, this is the lowest level and closest to the hardware, and end users never see this level. Okay, how the data is actually stored on the disk by using different data structures, indexes, storage blocks, and so on. User does not see this. Only database management system see this module and operates some managing, authoring this activities on this level. Okay. Next, if we are talking about this key point, internal level focuses on efficiency, performance and physical storage details, how actual data will be stored and where the actual data will be stored is decided on this level of phases. Next topic we have, okay, 2.1 topic is cleared now. Hopefully this topic is completely cleared. 3 level architecture, we have 3 levels and we already discussed the users level, conceptual, internal and physical database representation. Now you can read from the book each line and understand their concepts. If you have any difficulty, you may ask in the class. Next beta, we have mapping. What is the mapping? Mapping is the process of converting one level to another. Okay, it means if the process, in this process the data is at one level is related to the data at another level. 2 levels data means if we are transferring one data, means we have transfer previous details with the another level. Okay. Mapping means creating connection between these 3 levels. Mapping, since each level describes the data differently, mapping makes sure that changes at one level are correctly reflected at other level. ठीक है कि अगर आपका एक लेवल बेटा चेंज हुआ है तो उसके अकॉर्डिंग जो है वो आपका एसोसिएटेड रिक्वायर्ड या लेवल जो है इंफॉर्मेशन वो भी चेंज होनी चाहिए. दिस कॉन्सेप्ट ऑफ द मैपिंग. There are 2 main categories of mapping. First one, external conceptual mapping, connects the user's external view with the conceptual schema, ensures that when a user requests data, it comes from the correct part of the logical database. Okay? What is the main theme of external and conceptual mapping? Means that if the users request the data, इट कम्स फ्रॉम करेक्ट पार्ट ऑफ द लॉजिकल डेटाबेस. ऐसा नहीं होना चाहिए कि यूज़र आपको कमांड दे रहा है कि मुझे आप डेट ऑफ बर्थ दो और उसके पर्सपेक्टिव में वो किसी और की डेट ऑफ बर्थ आ रही हो या डेट ऑफ बर्थ ना आ रही हो, उसकी कोई और चीज़ आ रही हो, तो उस चीज़ की करेक्शनल और वो सारा कुछ चेक करना, आपस में कनेक्टिविटी देना, दूसरे कमांड की बेस पे उसका डेटा वापस रिटर्न करना. दिस इज कॉल्ड द एक्सटर्नल एंड कंसेप्चुअल मैपिंग. For example, when the customer views their name, account balance, it is mapped from the customer and account table in the conceptual level. conceptual level पे कस्टमर की एक टेबल भी होगी बेटा, एक अकाउंट की टेबल भी होगी. तो वहाँ से इन दोनों की 2 चीज़ें, डिफरेंट चीज़ें जो उसने नेम और अकाउंट बैलेंस रिक्वायर्ड किया है वो उसके व्यू में डिस्प्ले किया जाता है. अगर हम स्टूडेंट की बात करें तो सिमिलरली इफ़ स्टूडेंट वांट टू चेक देयर कोर्स नेम और कोर्स नेम, तो उसकी कोर्स की टेबल होगी, मतलब कोर्स एलोकेशन टेबल होगी और प्लस स्टूडेंट टेबल, तो उन दोनों का डेटा जो है वो मर्ज होके आपके कॉन्सेप्चुअल लेवल से गेट करके एक्सटर्नल लेवल पे प्रोवाइड किया जाएगा. नेक्स्ट बेटा वी हैव conceptual and internal mapping. कॉन्सेप्चुअल और इंटरनल मैपिंग में बेटा ये होता है कि कनेक्ट करते हैं हम लॉजिकल स्कीमा विद द लॉजिक फिजिकल स्टोरेज, इंश्योर्स दैट द लॉजिकल डिज़ाइन ऑफ द टेबल इज करेक्टली एंड रिट्राइव फ्रॉम द फिजिकल मेमोरी। लॉजिकल टेबल जो है वो आपकी प्रॉपरली करेक्ट होनी चाहिए, स्टोर्ड होनी चाहिए, और उससे आपको फिजिकली जो मेमोरी है वहाँ से डेटा प्रॉपर वे में आना चाहिए। In simple words, you can see or understand this hierarchy as we have 3 levels. First one, user. Second one, conceptual. Third one, internal. At conceptual, we have designer, that is designing the whole schema of or whole logical structure of our database. Okay. At internal level, we have DBA, that manages or controls all operations on physical data, where the data will be stored, where the actual data will be stored, or how actual data will be stored, and so on. Okay. At external level, we have users. User is data abstract or hide from users. At external level, we have hide the complexities of these internal or conceptual level from the users. Okay. So users just need their required data. In mapping, if user wants to see some data, they send command to the conceptual level. At conceptual level, we have schema, found query will analysis from that which tables required from the conceptual level and what are their basic association or relationship between that tables. Analysis is done by the DBA or at internal level, and DBA performs where the query exists. It will provide you correctly or retrieve from correctly data from the physical memory to the required user or destination place. Okay. And mapping is basically, in short, if you are talking about what is the mapping is basically like a bridge between these 3 levels. Yeah, these different levels. Next we have beta data independence. Okay, this is not a difficult. In this book, this is very easy wording is used. You can go and read. Once you read, you can easily understand about these responsibilities or changes what is occurring in this. Okay. Next topic we have data independence. The separation of data and application program is called a data independence. From the name, independent means data is not dependent on anything. They are completely separate from the data and application program. One of the biggest advantage of the database system is that data independence. Okay. It means you can change something at one level without affecting the other level. If you have a need to change anything on one level, either on conceptual level or internal level or user level, you can't send the effect on other levels. There are 2 types of data independence. First one is logical data independence and second one is physical data independence. In physical data independence, you can change the physical storage without changing the conceptual schema. Means you can change the destination of database where the data is stored. Yeah, you can, if you move the database from the hard disk to SSD, this is done. If application do not need to be modified कि हमें अगर कोई भी data change करना है या कोई डेटा स्ट्रक्चर चेंज करना है, कोई इंडेक्सिंग चेंज करनी है, इट विल नॉट अफेक्ट ऑन आवर कॉन्सेप्चुअल लॉजिकल स्कीमा. ठीक है. Simple is that in physical data independence means if we have change या DBA change any process on database, physical database या physical storage, it will not affect on our logical or conceptual data independence. Here are some key points are given. Changing the file organization and storage structures using different storage devices. We can modifying the indices, modifying hashing algorithm, changing access method. I already explained you these points. Okay, so you can read out this and cover this topic. Next we have beta logical independence. In logical independence, you can change the conceptual schema without changing the user's view or external view. Okay. If we change any on schema or at conceptual level of database, it will not affect on your external view. This is concept of logical independence. Here are some examples of given or key points are given. Means what we have to change: addition or removal of entities or relationships, and file database, new field adding into the file or table. I already told call you table we are using in our relational database when we are asking about or discussing about the file storing. Table is stored in form of files, okay, in the database. Changing the type of field and etc., if we are changing the attribute and type of attribute and so on, it will does not affect our external view, okay. This is a concept of logical independence. Next topic beta we have data models. In data models, representation of real world objects, events and their association is called a model. Database model is simply say that we organize or represent data in database, okay. Means how data is logically organized, structured and related to each other in database system is called a database model. Next, parts of database models are given. That first one consists of the following parts: structural part, manipulative part and set of integrated rules. In structure part, we have to define the set of rules, how database will be developed and specified according to these rules, okay. Next we have beta manipulative part. In this part, we define the types of operations what are to be performed on the data. For example, updating, removing, retrieving, deleting, changing, altering and modifying different queries on database, okay. Set of integrated rules means to ensure the accuracy, consistency of the data in database. Means we have proper and compact in consistent and completeness way we have to enter the data or efficiently data in the database according to the rules, okay. Next we have beta importance of the data model. Why the data model is important, why it is need. You can read it from here. Because we want to represent our real world objects, events and their association in a proper way or in a proper rules to hide the complexities from the users is done by the data model. In data model, we is used to communicate the tools for database designer, application programmer and users to interact with each other. A good data model enables the users to understand the organization for which the database design is developed. Basically, good data model is very important or necessary to design the good database. I already told you data model is what is the data model. It completely designing or a schema or structure of any data is called a database model, okay. Next we have the types of database model. Data models for there are three different types of data models are there: object based, record based and physical database. Further classify, we have moving forward into terms that is object based data model. In object based model, we use the concepts of like entities, attribute and relationships. What is the entity? You already know. If a person, place or thing, anything that is the part of your organization for your data is called a entity, okay. Entity is a person or place or thing. For example, student, for example, city name, for example, locality, for example, classroom, that is called an entity, okay. If we are talking about the attribute is the basic characteristics of entities. For example, if we have entity student, its characteristics means we have student name, roll number, its address, email address, its phone numbers and so on. These are basically attributes or characteristics of student. Next we have relationship is association between two or more entities. Relationship means what is our relation what is the association, how they are related to each other with their respective role. For example, if we have two entities, student and teacher, what is the relationship between student teacher taught the students and student teaches from the teachers. Okay, so this is called teaches. Student teaches the student, teaches the students. Teaches means a relationship between these two entities is called a relationship. Okay, next we have some type of object based data models are as follows. For example, first one, entity relation, already discussed. Semantic, object oriented. Semantic means they are meaningful. When we are discussing about the entity relation, they are drawing, processing their entities, their attributes, and their relationships all becomes a semantic. And object oriented means we have enrolled some objects. Next we have beta record based database model. In record based database model, it's basically used to describe the external or conceptual level database. Okay, they can also use to describe the internal or some external. This is also another type of data model. In further record based data model, we are classified into the three main data models. Named are mostly used and called, that is the hierarchical model, network model, and relational model. Okay, first of all, start with the hierarchical model. Data is organized in a tree like structure. This is called a hierarchical model. What is the tree like structures? We have parent and child structure. Okay, mean we have higher authority, next dean, then their departments, HODs, and then faculties, and then students. This is a hierarchical or parent child relationship, and tree like structure is called a hierarchical model. Each parent can have multiple children, but each children have only one parent. Means if here is an example of a higher authority. Okay, for example, if we are talking about the handle, window, and lock, these are the children, and above here it is one single parent, that is the right to. There is no multiple parents are of the child, so each parent can have multiple children, but each child has only one parent. This is the tree like structure in the hierarchical model, and this is the main scenario of this. Here it is some informational information is given that in IMS, sorry, information management system, and IBM is introduced this model in IMS in 1968. This type of information is for important for your MCQs type questions, not for the theory. Okay, next we have beta characteristics of hierarchical model. Okay, this is your assignment. You can read from your book, you can go through the Google search and read these characteristics of hierarchical model. I already told you what is the hierarchical model. Data is organized in a tree like structure, and it is also known as a hierarchy based model, and each parent is can have multiple child, but each child has only one parent. For example, if we are discussing about some hierarchy, so higher authority, for example CEO, and then we have managers, and then we have employees. So this is the basically hierarchical structure, and limitation of that this model is that difficult to handle many to many relationships. So remaining is the characteristics you have, and you can read from the book, but there is some disadvantage, that is important disadvantage, that is difficult to handle the many to many relationship in this hierarchical model. You already know, if we have teacher and student, for example, students have many relationship, many students have taught by many teachers, and many teachers taught the many students. So many to many relationship is complex and difficult to handle by the hierarchical model. Next we have beta network model. In network model, data is stored in the graph structure. In hierarchical model, we are discussing data is stored in the form of tree. In network model, data is stored in form of graph model. It allows many to many relationship. Last hierarchical model gives the limitation to that, and this network model allows that limitation. Okay. Network model was developed to overcome the problem of hierarchical model. Okay. It modifies the hierarchical model by allowing the multiple parent-child relationships, and these relationships are known as set in the network model. This is called a network model. In network model, we have in the form of sets to integrate many to many relationship in the model. Okay. So next we have beta characteristics of model, network model. This is your assignment. Okay. You can learn or read from the book and find out your difficulties. First, I have given you the characteristics of what is the hierarchical model. I have already told you. And next we have characteristics of hierarchical model. Next we have characteristics of network model. These are two assignments till now. Okay. Next model is relational model. Okay. Next model is relational model, and relational model you already know about the ER diagram. Okay. Entity relationship diagram. And relational means we have data represent in form of tables, or table. What is the table? Table means we have collection of rows and columns. Okay. Data is stored in tables with the rows and columns is called a relational model. This is most widely used model today. For example, student with the column student ID, name, age. This is means we have table and its attributes columns. Names are student ID, name, and age. If we are putting their data into that table, this is becomes a rows of that table, and that table is known as relational. Okay. Advantage of that, this is very simple model, flexible, and structure query language supportive. Okay. That's why this is mostly widely used model today. Okay. If we are talking about the network model, this is the advantage of overcome of problem of hierarchical model, but most flexible than the hierarchical model, and the limitation was still complex to design and maintain the different many to many relationships. So overcome these problems by our relational model, and relational model easy, flexible, simple, and supportive of SQL structures. Okay. So easily can handle by the user. Database relational database terminologies are given. First one is beta primary key. What is the primary key? Relation, tuple, attributes, domain, degree, cardinality. Okay. First of all, we have primary key. Primary key means we have unique or identity of a table is column is a primary key. Okay. On the basis of that, we can easily apply constraint on the table. Okay. What is a relationship? Relationship means data is stored in relations, like for example tables. In terms we can use that term is called a table. Table is rows and columns. Okay. Tuple is also known as a rows. Okay, or record. Here are the given example of tuples. Attributes are basically column names are called attributes. And domain is a collection of all possible values of one or more attribute is called a domain. For example, beta, if we are filled about the class name, name of any dotted class is known as a class domain. Okay. Similarly, the registration domain is a collection of all possible registration number. This is called a domain. Means any registration lie definitely into the registration column. That means this is the registration domain. Okay. Next we have beta degree. Degree means the number of attributes is called a degree. Okay. Cardinality, number of tuples, number of rows. Number of attributes means number of columns. Number of tuples means number of rows is called a cardinality. Means if we have a table, we can easily calculate the degree of table and cardinality of table easily. Okay. Next we have beta advantages of relational database. We already last time in last lecture I will given you some functionalities or characteristics of database model. Now we have advantages of relational database model. This is also done by yourself. Next topic we have bit of, and this is only just 5 uh, advantages of relational integrity means we have set of rules. According to that rules, our model will perform. Data independence we already discussed. Structural independence means we already discussed. What it means? Data independence means data is completely independent. Structure means designing or schema is completely independent. Data consistency and accuracy means multiple redundancy and multiple entries and multiple relationships. Avoid the data accuracy or accuracy and consistency, so remove the redundancy and multiple entries to maintain the accurate and correct data in proper form is called a data consistency and accuracy. Data retrieval and sharing, data can be easily retrieved any row any from any column is called data retrieval, and it can be shared to different users at multiple times is called a sharing. Okay, next we have beta physical data model. This is our last topic. Physical data model means we have physical actual data storage or called a database. Okay, next topic we have beta functions of DBMS that we have to discuss in next coming class. So that's it for today lecture. What we have to learn about today lecture: first of all, we studied about the three level architecture, mapping between the levels in data independence, and different database models and type of database models. Okay, next we have beta functions of DBMS. This is 2.6. Before the 2.6 you will complete your topics 2.5 till 2.5. If you have any question, any query according to any term or any topic, you may ask in next coming class. Okay, thank you for that. Till that you have to complete your assignment 2, characteristics of hierarchical and network model. Thank you. Allah Hafiz.